Hi guys, welcome to one more video. In this video, we'll take a look at add numbers to problem. Recently, this problem is being asked in Microsoft, Bloomberg and Facebook. So for some reason, as a recording of this video, this is a very popular problem. Difficulty level is medium on this problem and it's related to linked list. So let's look at problem description and then we'll figure out different approaches and their pros and cons. So let's start with problem description. Let's see how the reverse list look like and how we'll actually do it in code also. So we'll try to solve the same problem without reversing the input list, and we'll be using stack as our data structure to solve this problem. Okay, so this will be our third approach to solve this add number to problem, and in this approach we will neither reverse the input list nor use stack. Okay, so this is our problem description for add numbers to problem. So basically we are given two non-empty linked lists. They both represent non-negative integers. Now the head of the linked list will point to the most significant digits. So in this example, if we consider 7243, the head will point to the 7000 or 7 number. And for second linked list 564, the head will point to 500 or 5. And our job is to add those two numbers represented in the linked list format and return the output again in the linked list format. So let's go to the whiteboard. Let's look at the challenges in this problem and then understand the approaches and come back and run code. So to figure out our approach to solve this add number to problem, we'll take this example. So we have two lists. Our list 1 L1 has numbers 70243 and our list 2 has numbers 762. So if we just do simple math of these two numbers, then it'll be 70243 and 762. So this is our simple addition of these two numbers. So our output should be a list of 71005. So let's see how we'll solve this problem, because the two lists, they're of different length, and if we sequentially traverse the list and if we add these two numbers, then it'll be 7 plus 2 9, and then we move on to next node. So now these would be 6 plus 4 10. So we need to put the carryover to the previous node, and in a single linked list there is no easy way to go to previous node, right? There's only next pointer, and even if we do that, this will also result in carryover. So we need to go to even further previous node. So it's getting tricky. So let's see how we'll do that. So one way to solve this problem is, if we think that if we can reverse the list, then how does it look like? So let's see how the reverse list look like and how we'll actually do it in code also. So this is our short code to reverse the list. So let's run this code on this list so we better understand it. So let's start by this previous pointer. So I have a previous which is pointing to null. So let's say this is my previous, or yeah, let's say I have previous over here which is null. So my previous points to null, and then we have a while loop for the whole list. So this is my node pointer pointing to head. So we'll start from here. So in the while loop, what we do is we say we store the node.next in a temp pointer. So node.next is this guy. So let's say this is my temp. And what we do next, once we have the next pointer saved, we do node.next as the previous pointer. We want to reverse the list, right? So we say node.next is previous, and previous is null. So node.next, so this becomes null, right? Node.next instead of this becomes null. And now what we do, we change previous to node. So previous comes here. This still remains null. And where do node goes? Node goes to temp, right? Temp was node.next. So node goes here. So after one iteration, this is how our list looks like now. So let's repeat these steps until the node reaches null. So what happens? We record that node.next in temp. So node.next is temp. So I'll just write T for temp. So node.next is temp. And what we do, node.next go to previous one. We're reversing the list. So node.next goes to previous, and previous is here. So node.next goes to previous. So do you see the effect? It's starting to reverse. And so we just now update the node. So previous becomes node. So previous comes here. And node goes to the next node. So node comes here. And again, we continue it.
So we record the temp, which is node.next. So we say we just store this in temp, and node.next becomes previous. So node.next becomes previous, and then we just update the variable. So previous becomes node, and node becomes temp. So node comes here. So same thing, right? We go temp, we store node.next in temp. So this becomes temp, node.next previous. So node.next goes to previous, and then we just update the variable. So previous becomes node. So previous becomes node, and node becomes temp. So this is my node. And one more time, right? Same thing. So we record temp, which is node.next. So this is temp, which is null. Node.next previous. So node.next becomes previous, right? So node.next becomes previous, and then we just update those pointers. So previous becomes node, previous comes here, and node becomes temp. So node comes here, which is temp.
So node is null, and if node is null, we end the loop and we say return previous. That's the head of your new reverse list. So now this is our head, which is the list. So our list becomes 34207. That's our reversed list. So let's reverse the second list also and then see how it looks like. So this is how our both list will look like if we reverse them. So 34207, 34207, and our list 2 would be 267, 267. So we start with these two pointers. 2 plus 3 will say 5. Then we go to next node. We do 6 plus 4, we'll get 10. So we'll put 0 in the node and we'll carry forward 1. And now we do 1 plus 2 plus 7, we get 10. So we put 0 in the node and we carry forward 1. 1 plus 0 is 1, and then 7 as 7, and that's our list. Once we have done this, we'll again reverse this list. So 50017 will become 71005. So let's look at this final piece of code where we add the two lists on the computer and then we'll run the whole thing. Okay, so this is our final code. We have two functions called reverse list and add two numbers. Reverse list is exactly same as what we had discussed on the whiteboard. So we'll not go into much detail of it. We'll just look at add two numbers method. So what do? We start with a two input list, we reverse them, and then we create a dummy node. This will be the head of our output list, and we create a node pointer which will just point to our current addition or current digit addition, and we'll keep moving to next. So, and then we have this carry variable, and we start with a while loop saying that while there are nodes in L1 or L2 or carry is greater than 0. So imagine a scenario where last two nodes of both the list are, let's say, 5 or 6. So our addition would be 5 for 5 it'll be 10, for 6 it'll be 12. So we'll put that summation, and then we still need to create one more node for the carryover. So that's why we have this carry greater than 0 in the while condition. So what we do in the while loop, straightforward addition, right? We create a sum variable, so carry forward from previous addition and then add the digits from both the list. So sum equal to carry plus L1 value plus L2 value, and if sum is greater than 0, then create a carry variable and make sum as sum mod 10, and then create a node for that summation. So node.next will be new node with that value, and then we just move all the nodes to next pointer. So node.next node moves to node.next, L1 moves to L1.next, and L2 moves to L2.next. So that logic or that while loop will give us the whole list with the addition of two input list. And as we discussed on the whiteboard, once we have done this addition, we reverse the output list and we return it, and that's our output. So let's submit this code, make sure that we pass all the test cases. So there you go. We pass all the test cases. However, let's look at problem description for one more time. So there's a follow-up question. What if you cannot modify the input list? In other words, reversing the list is not possible. So imagine a real interview scenario. We have solved this problem, we're happy, and interviewer throws the curveball to us saying that, hey, can you think of any other approach where reversing the list or reversing the input list is not allowed? So let's see how we can come up with another approach where we don't have to reverse the list. So we'll try to solve the same problem without reversing the input list, and we'll be using stack as our data structure to solve this problem. So first of all, we'll push this list into stack, and then we'll have two stack. And then if you guys understood the previous approach where we were taking two digits, adding it, taking next two digits, adding it, and then managing carryover. So we'll run similar approach on stacks, and then we'll have our output list. So let's look at list to stack code. So it's simple while loop. For node is not equal to null, push the digit into stack, and then node is equal to node.next. So let's see how our two stacks will look like. So stack 1 for list 1, stack 2 for list 2. So first of all, we'll push 7, then 0, then 2, then 4, and last 3. And for list 2, we'll push 7, 6, and then last 2. So this is how our two stacks will look like. And then we'll run this code to add numbers. So we'll start with a dummy node, which is like new list node, and then carry variable. So let me put a dummy node. So by default, the constructor of list node puts 0. So we'll just put 0. And then we'll run a while loop while stack 1 or stack 2 are not empty. Run this code. So we have some variable for the carryover from the previous addition, then plus equal to stack 1 pop, plus equal to stack 2 pop. So we have our sum of two digits and previous carryover. And then we put that value in the dummy. We just do mod 10. And if the number is more than 10, carry will obviously be 1. And once we put that number in the dummy, what do? We create a head node such that value is carry and the next pointer is dummy. So there'll be a head node whose next pointer points to dummy. And then after that, what do? We move dummy to head. So dummy will come here. So let's run this code and let's see how our list comes out to be. So we have dummy node. We just pop the two numbers from stack and we add it. So we'll pop 3 and 2. So 3, 2, we'll put it in dummy. So we'll put 5 and then we'll create a head node with carry value, which is 0, and next pointer goes there. And then we set dummy equal to head. So dummy comes here, right? So this is how our list will look like after first iteration. So let's keep doing this and let's see how our list grows. So 4 plus 6, 10. Now 10 mod 10 would be 0. So this will be 0. Carry would be 1. And dummy will come here. Now 2 plus 7, 9 plus 1, 10. So 1, 7, 2, 10. Again this will be 0. Carry would be 1. So head would have 1 and then dummy comes here. So 2 and 7 are done. So stack 2 is empty. Stack 1 is left. So this is 0. So 1 plus 0 is 1. and carry would be 0 and dummy moves here. So this is gone, and then finally we have 7. So this becomes 7. We have carry, which is 0, and dummy goes here. So this is our output list formed by this logic, and once this while loop is done, what do? If dummy value is 0, we return dummy.next. So we'll return from this node. So this will be our output list. So just in case if our two most significant digits, if they resulted in carryover, this would have been 1, and in that case we would have returned dummy node. So we could have 171005 in that case. So this will take care of that final digit carryover. So this is our code to solve this problem using stack. So let's run this code and make sure we pass all the test cases. Okay. So this is our final code. We have list to stack method, which is pretty straightforward. And then we have add two numbers method, which we just went by on the whiteboard. So we have a while loop running through both the stacks, and then we have dummy and head nodes creating the output list, and then finally returning either dummy.next or dummy node based on the value, whether it's carryover or whether it's 0. So let's submit this code. So there you go, all the test cases passed. So that's the approach of using stack. However, I want to mention that this approach is a little bit debatable, since we're using stack, so we are not reversing the input list. But if you look at stack values, they are actually reversed of the list values. So technically we're still reversing the list. So if you want to totally avoid that, there's one more approach where we can avoid using stack also. So let's take a quick look at that approach and let's see how it works. Okay, so this will be our third approach to solve this add number 2 problem. And in this approach, we will neither reverse the input list nor use stack. We'll solve this problem in two parts. In first part, we'll simply add all the numbers and form a list. And in second part, we'll take care of carryover and we'll prepare the output list in the required format. So this is our code for the first part. So let's run this code and let's see what we get after part 1. So first of all, we'll start by taking the length of both the list. So we'll have n1 and n2. So in this case, n1 will be 5 and n2 will be 4. And then as usual, we'll have dummy node with value 0. So let's say this is our dummy node with value 0. And we run a while loop till n1 is greater than 0 and n2 is greater than 0. First of all, we'll have sum as equal to carry, and then we'll check if n1 is greater than equal to n2, then we take value from list 1. So n1 is 5, n2 is 3. So we take 7 from this list, put it in the sum, and we do n1 minus minus. So this will become 4, and L1 goes to L1 dot next. And we come to second if condition. Is L1 less than N2? Not yet. So we'll not go into this if condition. We'll create a new node with sum equal to 7 and dummy as the next pointer. So we'll create node 7 with this as next pointer, and just like previous approach, we'll move dummy to head. So dummy will come here, and we'll repeat this iteration, or we'll repeat this while loop. So now we'll come here, sum is again equal to carry, which is 0. n1 is greater than n2, yes. So sum will be 0, second node, n1 minus minus, so this becomes 3. L1 moves to L1 dot next, and we still don't go into this. Sum will be 0 and dummy would be next node. So 0, and this will become dummy. Now let's do that again. So sum is equal to carry, which is still 0. Yeah, actually we don't need this carry for now, right? Yeah, sorry about that. Okay, so n1 is greater than n2. Yes, 3 is greater than or equal to 3. So sum would be 2. n1 minus minus, n1 becomes 2. Now this time n1 is less than or equal to n2. So we'll take this guy also. So we'll do 2 plus 7, which is 9, and we'll put it over here. So 9, and same logic, dummy will go ahead. And this will become 2. So we'll repeat this logic. So we'll take 6 and 4 now. So we get 10 over here. Notice that we are putting 10 as is. We are not doing any carryover or anything. This becomes 1, 1. And finally we do 3 plus 2, which is 5. And our dummy stays here. So this is how our list will look like after executing the part 1 of this approach. Okay, so this is our second part for this approach. So we start off with having a node pointer point to this dummy list. So we'll have a node pointing to this list, and we'll start off with dummy is equal to null. So let's say D, this is null, and then carry is equal to 0. And then what do? We run while loop while this node is not equal to null. So we'll be traversing this list, and then we'll be creating a new list, which will be the final output list. So what do we do this in this while loop? We have node value plus carry, which will be our new sum. So 5 plus 0, right now carry 0. So we'll have 5 plus 0, and then we'll create a new node temp with new sum mod 10, and dummy is his next pointer. So we'll create a new node temp with 5 and next node as dummy. So this is my temp, and after creating this, we just have our carry variable. In case if new sum is more than 10, then carry will be 1. We move dummy to temp. So dummy comes here, and node goes to node.next. So node goes here. And we'll just keep repeating this in while loop. So let's do that, and let's see how our list forms. So now we have 10. So our node value new sum would be 10, and new sum mod 10 would be 0. So we'll have 0 over here. Next we'll point to here, and dummy goes here, and node goes here. Now when we do 9 plus carry, remember we had 10, so our carry is 1. So 9 plus 1 is 10. So again, new 10 mod 10 would be 0. So 0, and we have one more carry. Dummy goes here, and node moves to next pointer. Now 0 plus 1 carry, so 1. New sub mod 10, 1 mod 10 will be 1. So we create a node 1, next pointer, and dummy moves here, and node moves here. Now this is pretty straightforward now. Same logic. So 7 will come here, dummy will move here, and node will move here. And finally 0 will come here, dummy will move here, and obviously node goes to the null pointer. So this is our list formed in part 2, and this is our required output, right? 71005, 71005. So finally what do? If dummy value is 0, then return dummy.next. In case if this was 1, then we would have returned dummy. So that's our required output, and that's our code which will solve this problem. So this is our final code for this approach. So we have list length method, which simply just counts the number of nodes and return the length of the list. So we'll call that for both the list, so that we have n1 and n2, and then we run the while loop for n1 greater than 0 and n2 greater than 0, and then we create our list at the end of part 1 of the approach, and then we work on that list in our part 2, where we take care of the carryover and we again kind of reverse the output list. So we have our final list in the second while loop, and then we have our return statement. If the dummy node is 0, then return dummy dot next, and if dummy node carries a carryover, then return dummy node. So let's submit this code. Let's make sure we pass all the test cases. So there you go. So that's it, guys. These are the 3 approaches to solve the same problem. So I just want to show you guys one more thing. Since you guys have stuck with me till the end of the video, I want to show you guys that while solving this problem, we've actually solved 2 more problems that are reverse list and add to numbers that we have inherently solved while solving this problem. So let's see those problems. So this is the reverse list problem, where we're given a linked list, we just need to reverse it. So we simply copy the code of reverse list and we put here, and we just change the node to head. And let's run the code. So there you go, guys. We've solved the reverse list problem while solving this add 2 numbers problem. And if you guys want to try it, there's a add 2 numbers problem. We just did add numbers 2 problem, but there's a easier version of this problem. And if you apply the same logic, we can solve the same problem. This is easier since the least significant digits are at the head of the linked list. So we don't have any issue of reversing the list or using the stack or all those issues. We simply keep adding the numbers and keep moving ahead. So there you go, guys. We solved 3 problems while solving this one problem. So if you guys like the video, give me thumbs up. If you have any feedback, any suggestion, then let me know in the comments box. And then as usual, subscribe to the channel for more videos. And I'll see you in next one.